The octopus is a strange creature. Imagine this: a silent aquarium, the clock striking midnight. A prisoner without bones scans the room with eerie patience. Its name is Inky. And then, something almost impossible happens. Inky spots a gap barely the width of a finger at the top of the tank. It slips through like living liquid. Soft skin flowing, cold floor beneath, a faint, sticky sound echoing in the darkness. It moves across the room, meter by meter, toward a 50-foot-long drainage pipe swallowed by shadows. And then, it vanishes, back to the ocean. A heist so elegant it would earn the respect of the most cunning burglars. But the real mystery isn't the escape itself. How could a jelly-like mass possibly plan such a jailbreak? Where does that intelligence come from? Inside that pliable body lies a biological machine unlike any other, defying conventional rules of evolution. Before we delve into the secrets of Inky's extraordinary mind, I want to know what you think. Are you shocked by Inky's daring escape? Comment 1 if you believe Inky is truly a genius. Beneath the ghostly moonlight filtering through the water, Inky's daring escape was only the beginning. But what fuels such absolute courage? The secret lies in a triple heart system, a biological machine unlike anything in the human world. Picture this: 3 hearts working in perfect harmony. 2 auxiliary hearts tirelessly pump oxygen through the gills, while the central heart shoulders an enormous burden powering 8 muscular arms. Without any part of this system, crawling 50 meters through a narrow, friction-filled pipe would crush any creature instantly. A paradox emerges. When Inky swims, the main heart stops beating, leaving only the 2 auxiliary hearts to sustain life. For humans, swimming is strenuous. For the octopus, speed literally takes the core heart offline. This is not mere survival. It is a refueling station of evolution, a living testament to how environment and life's pressures sculpt intelligence. Every squeeze, every crawl, every calculated risk is fortified by this decentralized power. Could you endure such a challenge with only 1 heart? Inky can. If this shocks you, comment 1. If you're still trying to picture it, comment 0. In the crushing darkness of the glass tank, Inky did more than just crawl through a pipe. He observed, he tried, he failed, and then he succeeded. Imagine a boneless creature, 3 hearts beating in harmony, each arm like an elite special ops unit, silently working to manipulate a lid so tight it seemed impossible to open. Pop, pop, pop. Suckers latched, twisted, lifted, calibrated to the millimeter. But why can an octopus accomplish what many higher animals give up on? The answer lies in extreme curiosity and a decentralized neural network. Each arm doesn't just follow commands from the central brain, it makes its own decisions, sensing chemicals, tasting the environment, probing for prey or obstacles. It's a distributed special ops system where every arm is detective, warrior, and engineer at once. From opening jars to avoiding piercing light or encountering predators, curiosity becomes a problem-solving tool, a complex symphony of sensation, memory, and action. This is not mere survival. It is intelligence emerging from a soft, self-governing body, confronting a harsh environment where every decision is a calculated step of an underwater explorer. The ocean is always still. Yet, inside the glass tank, a small chaos erupts each night. Light from the aquarium lamps glints off the water's surface, while Inky and my fellow octopuses move in secret, orchestrating mischief. A spray of water bursts into the air. A lamp shatters in a sudden explosion. Sand on the tank floor spirals upward in perfect, whirling vortexes. But why would a soft-bodied creature with 3 beating hearts be so intent on such playful antics? This is no meaningless game. Each action is an experiment, a test of curiosity and problem-solving. When a sucker latches onto a hot lamp, it doesn't destroy, it controls. When twisting lids or manipulating small objects, it learns mechanics and force, calculates, adjusts, and repeats. The decentralized nervous system allows each arm to function as an independent unit, sensing the environment, identifying objects, and deciding on actions. It's a sophisticated special ops system, each arm simultaneously detective, engineer, and warrior. In every playful maneuver, we witness curiosity transformed into survival strategy, a symphony of intelligence, sensation, and action. Even within the confines of a glass tank, the octopus turns its world into a living laboratory, where intelligence is honed through challenge, failure, and success, a vivid testament to the extraordinary agility of underwater cognition. Light pierces through the water, casting ghostly patterns across sand and coral, but a creature begins to vanish before our eyes. An octopus, its body contracted, eyes rising like sentinels, glides in the sinuous arc of a crescent fish, perfectly mimicking a harmless predator. Moments later, two arms extend, black and white stripes dancing across its skin, recreating the deadly visage of a lionfish. But how could a soft-bodied creature with three synchronized hearts wield such instantaneous transformation? The secret lies in a decentralized nervous system and intelligent pigment cells. Each arm functions as an elite special ops unit, remembering, observing, and reproducing the shapes and movements of other species. The chromatophores on its skin are not mere color organs. They act as a biological LED screen, controlled with precision in every breath, every movement, perfectly tuned to the surrounding environment. This is not just camouflage. It is a strategy for life, a method to lure predators, protect itself, and showcase the intelligence nature has endowed upon the octopus. In each transformation, we witness the fusion of observation, memory, and inference, a dance of survival, where every cell, every arm, every hue contributes to a living neural architecture, proving that intelligence need not be bound to a backbone, but can flourish within the soft, fluid body of the ocean. Darkness floods the aquarium. Neon lights flicker across the water's surface. An octopus faces a mesh that blocks its path to food. It does not rush. It pulls back. Each tentacle probes, exploring every thread. A frozen moment hangs in the water. Then, action. But how can a spineless creature plan ahead? The answer lies in a decentralized neural network. Hundreds of millions of neurons stretch from its head to every tentacle. They allow observation, calculation, prediction, a mobile command center in a soft, fluid body. Each arm, each chromatophore, each subtle movement is orchestrated toward survival. This is strategy in motion. The octopus does not merely react. It envisions possibilities, tests scenarios, selects the optimal path. In that suspended second, we realize intelligence is not reserved for creatures with backbones. It lives in neural connections, in curiosity, in foresight. It challenges every definition of consciousness, strategy, and life beneath the shadowed depths of the ocean. Neon light flickers across the artificial rocks. Tentacle after tentacle reaches out, like elite special ops units moving with calculated caution. But the strangeness is not just in the motion. Each limb, each tentacle, seems to decide its own action, independent of central command. How is that possible? The octopus's nervous system is a masterpiece of decentralization. Over 500 million neurons do not cluster in a single brain like humans. They spread throughout the body, turning every tentacle into a miniature command center. When one tentacle senses danger, it reacts instantly synchronized with the body, yet retaining autonomy. This is not mere reflex. It is a living, strategic network where each part can think independently while serving a collective goal. We witness a creature both soft and powerful, operating like a covert military alliance right before our eyes. Every movement carries intelligence, foresight, and purpose. Imagine a spineless being, yet possessing decision centers scattered across its body, simultaneously independent and coordinated, flexible yet strategic. This extraordinary design raises a profound question. Must intelligence reside in a single centralized brain? Or can it emerge as a biological network where every unit is a tactical player in the symphony of survival? A tentacle brushes against the rock. A subtle vibration ripples through the aquarium. But the strangeness is not just in the sensation. The tentacles taste the world. How is that even possible? Each limb is covered in millions of chemoreceptors. They do more than detect chemicals, they translate information into experience, much like fingertips sampling every fragment of the environment. As a tentacle sweeps over sand or drifts through seaweed, it records scents, flavors, even textures, sending signals back through a decentralized neural network. Every motion, every stretch and curl becomes a miniature autonomous exploration, simultaneously self-directed and coordinated. Imagine a creature whose tentacles are sensing centers, each one hand, eye, and nose at once. A mobile laboratory, experiencing every detail of its surroundings without a centralized brain. This image is more than science. It is a metaphor for perception and consciousness, where the boundary between body and environment blurs, and each tentacle becomes a living library of intelligence, independent yet interconnected. And here, within this soft yet powerful being, we witness a paradox. Intelligence needs no rigid form. It spreads, it flexes, and it tastes the world in ways humans have never imagined. Light pierces the deep emerald waters. The octopus's eyes glint like crystalline lenses. But they do more than see. They observe. How is that possible? An octopus's eyes are masterfully engineered, with lenses that adjust to light and optimized retinas that capture fine detail in utter darkness. No blind spots. Each blink functions like a living film camera, recording every subtle movement in its surroundings. Combine this with the decentralized nervous system we've just explored, and these eyes do not merely observe, they interact with the tentacles, transforming vision into a holistic sensory experience. Imagine a creature where eyes and limbs merge into a single perceptual command center, translating every flicker of light, every hue, every shape into living information. A mobile control room where sight and sensation intertwine, autonomous yet fully integrated. This vision unveils a metaphor for consciousness. Intelligence is not confined to the brain. It radiates through the body, sensing the world in ways humans could scarcely imagine. In the silent depths of the ocean, the octopus's eyes become a window into alien intelligence, simultaneously beholding, understanding, observing, and experiencing. The deep ocean whispers its secrets. But the skin? It listens too. A recent experiment left scientists astounded. The octopus reacts to light even when its eyes are covered. How is that possible? Its skin is a living sensor network, studded with opsins molecules once thought to exist only in eyes. Each chromatophore functions as an independent light receptor, detecting color, intensity, and even subtle shifts in shadow. The result is breathtaking. The octopus sees through its skin, turning its entire body into a dynamic visual map, reacting instantly to the environment. Imagine a tentacle fortress, moving and sensing simultaneously. Every limb, every patch of skin acts like an elite reconnaissance unit, feeding the central nervous system a panoramic view of light and color. Vision is no longer confined to the eyes, it is distributed, alive, and fully immersed in the surroundings. This shatters our understanding of perception. Sight, once thought the sole domain of the eye, now radiates across the body, in a decentralized network that blurs the line between sensing and acting. It seems the ocean has granted the octopus a sixth sense, a biological radar for survival, art, and stealth. Every glimmer, every subtle hue on coral or sand is felt before it is seen. An alien intelligence woven from skin and flesh, a living testament to evolution's boundless creativity. And here lies the next mystery. If the skin can see, how does the octopus decide what to display and how? The answer opens a window into the art of communication and camouflage, a hidden world we are only beginning to glimpse. The ocean is more than a hiding place. It is a living, sensing network. In the deep, ghostly blue darkness, the octopus orchestrates its eyes, skin, and tentacles like a symphony of perception. A single experiment revealed something extraordinary. When approaching prey, it sees with its eyes, tastes with its tentacles, and simultaneously senses light with its skin. This combination is no accident. But how is that possible? Its decentralized nervous system allows information to flow across the body without waiting for the central brain. Chromatophores and opsins embedded in the skin act as elite reconnaissance units, responding faster than even the eyes. Tentacle, vision, light sensing all fuse into a unified sensory network, optimized for hunting, camouflage, and communication. Imagine a biological machine where each tentacle is a sensory branch, every patch of skin a visual display, and the entire body a living map of reflexes. Not only does it perceive, it decides in real time, merging sensation and action into an extraordinary evolutionary talent. This is not merely intelligence, it is sensory transcendence. Proof that perception can be distributed, multidimensional, and artful. And if the whole body can sense and react, where then lies the ultimate limit of octopus cognition? The answer unveils nature's boundless creativity, where evolution and intelligence converge in ways we are only beginning to grasp. The octopus is a strange creature, but its intelligence is even stranger. Scientists have watched in awe as one deftly unscrewed a glass jar in a laboratory, only to vanish into the labyrinthine coral beyond. A simple act? Hardly. It's evidence of independently evolved intelligence, a cognitive process completely detached from primates, yet achieving the same astonishing results: planning, problem-solving, and creative innovation in a complex environment. But how could a boneless invertebrate develop such advanced cognition? Its decentralized nervous system, perfected eyes, tentacles that taste the world, and skin that senses light all converge into a sophisticated evolutionary machine, where each part is both tool and processing center. This is the intersection of biological architecture and intellect, proof that evolution can craft forms of consciousness completely unlike our own, yet equally effective. Imagine a distributed intelligence, where every tentacle, every patch of skin, every neural branch is a ray of awareness. The octopus does not merely survive, it innovates, adapts, and challenges our very notions of cognition. If intelligence can evolve along such independent pathways, then where truly lies the boundary between consciousness and survival? Why must the octopus be intelligent? Imagine a boneless wanderer navigating a coral labyrinth, where every shadow could conceal a trap. Researchers have observed an octopus evade predators by changing its color and weaving its tentacles in intricate patterns, a display of tactical brilliance. It doesn't merely react. It predicts, experiments, and adapts. But what drives the evolution of this independent intelligence? The ocean is a crucible of survival, a world of constant peril. Here, evolution forged a biological supermachine, where each component, eyes, skin, tentacles, and a decentralized brain, functions as an elite special ops unit. Intelligence is no longer a luxury. It is a weapon of survival, the only path through the fragile line between life and death. Look deeper. The octopus teaches us that intelligence is not just knowledge. It is adaptation, observation, and strategy. In the shadowy expanse of the deep sea, cognition is instinct. If environments can sculpt independent architectures of thought, can we ever truly comprehend the full spectrum of consciousness beyond humanity? What can we learn from the octopus? In the shadowy depths, where the ocean pulses like the heartbeat of the planet, an octopus pauses. It does not rush. It watches, senses, and decides. From a decentralized intelligence to flawless eyes, from skin that perceives light to tentacles that taste the world, each part of its body is a strategic machine, an independent unit of cognition. But this intelligence is not for show. It is humility in action, a survival strategy in a universe that forgives nothing. Looking at the octopus, we confront a paradox: immense cognitive power paired with profound modesty. It reminds us that intelligence is not for domination, but for integration, learning, and survival. Imagine applying this lesson to our own lives. Every choice, every observation, every action, a blend of vigilance and humility. In the vastness of the cosmos, the octopus is not just a marvel of nature. It is a mirror of intellect and character, a guide to existing without arrogance, a model for living while continuously learning. The ocean whispers its final lesson. Beneath ghostly waves, the octopus glides a master of intelligence, humility, and adaptation. It survives not through sheer strength, but through foresight, curiosity, and harmony with its surroundings. Why should we stand in awe of this creature? Because it teaches us that true intelligence is inseparable from respect. Respect for life, for complexity, for the unknown. Each neuron, each chromatophore, every decision is a testament to the elegant machinery of evolution. We too can learn, observe, adapt. Question: bring the octopus's lessons into our lives, curious yet humble, acting with understanding, approaching nature with wonder and reverence. The ocean has shared its secret. Will we listen? Will we act?